you know that spreadsheets can be really, really cool and useful for many tasks, especially if you are a user that had been doing stuff with that tool for many years. You become a professional in that. You know how to do a lot of stuff, you know the secrets, and you can not only enter data and clean it and sort it, you can also do analysis, a quick plot. And probably you have also suffered some of the limitations that the spreadsheet has. Usually there is a potential danger on overwrite information or to transform to incorrect format some data. And probably if you use a spreadsheet has suffered about dates, that format can be tricky. I'm come from a country where we use the comma as a decimal mark and the dot as a thousands and mark. So all that transformation when someone from a country that don't use those marks send me information can be really tricky. And sometimes it's really hard to separate in spreadsheet the data entry task from the analysis task. So there's where programming languages enter in this equation. That is when it's good to start to think, well, perhaps it's good to invest in the time and the effort that means to learn a programming languages, because it can make more easy to handle this kind of task. The other thing that programming languages will give us, one of the advantage, is that we can have some kind of recipe or step-by-step task and analysis we do, how we read the data, what transformations we do, what cleaning we do, what kind of visualizations and calculations. When we have that kind of recipe available, it is more easy to understand what is going on in the analysis of that data. I don't know if it happens to you, but sometimes when I work in a spreadsheet and it's complex, even if I did it by myself, if I have to open that in 6, 7 months, I will need to invest some time on understanding how I calculate this, how this formula is built, where in this workbook on this spreadsheet I'm using the data, where this data come from. And sometimes that is even difficult if the spreadsheet was done by someone else. Someone just sent us that and we need to figure it out what is going on. I'm not saying that reading a code for a programming language is straightforward, but because it is step by step and it's like a recipe, usually it is more easy to understand what we are doing and what are the steps and the logic behind that processing of the data. So saying all this, we are going to look at R, which is the programming language that I use daily and that I enjoyed a lot. And I will invite you to, if you can, to try to follow along what I'm doing. I will share on the chat. Give me a minute that I will share a link to an RStudio Cloud project. So the idea is that if you enter to that link, it will be open a website that will show you an RStudio IDE with an R project with everything we need to try to code today. I will share my screen, but please, I will be paying attention to the chat. So if you have any issue, any question, please interrupt me, and we are going to try to solve it together. So everything good? It's okay? Okay. Awesome. Okay, I will share the screen. please let me know if you are seeing a screen that say resuming project. Are you looking at that? Yes, okay, thank you. Thank you for those thumbs up. If it is the first time that you enter RStudio Cloud, you will have to create an account, but if you have a Google account, you can use that to log in. So when you log into RStudio, RStudio is what we call IDE, is an integrated development environment. People who code usually use one of these software. Another one that is very well known and used is Visual Studio Code, for example. We are going to use RStudio because it's the one that I use, just because of that. It's not that it's better from others, but it's the one that I'm used to use. So when we launch RStudio, RStudio will also open the R language in the back. And we will be communicating with the language through this interface. I will move this. That is my Grammarly, so that helped me with my English. So one of the first things that we can do is to speak with R is to use what we call the console, which is the first tab that appear here. In the other side, we have some tabs here, the environment, that is kind of the memory. So we are going to be loading data and saving calculation and processing here. And then we have another tab that it shows the files that we have in our project, and then we are going to see also plots and presentations and some other kind of different information that we are going to see through the workshop. So the first things that we can do to interact with R is actually right here, something like a calculation, like we do in a cell, in a spreadsheet. So I can put 2 plus 2, and R will be a really nice calculator and will return a 4. So this is what we call an interactive mode, because I'm going to be writing and R will be answering with the result of whatever function or calculation I will put in the prompt. So we can also start to save. For example, if I want to use that for in the future or in some other process, I need to store that. In a spreadsheet, we usually have the formula in the cell, and we are going to see the result. Here, to save that for and be able to use it in the future, we need to create what we call a variable or an R object. So we call this variable total, and I will use that little arrow that is like an equal, and is the assign operator. So when I want to save something to a variable, I will add the name of the object or the variable that I want to save the result, and I will add this assignment operation, the arrow, and then I can do 2 plus 2. And when I press enter, this time I don't have the 4 here. You see, it's not in the prompt. It doesn't show me the result because it's now in the variable that is called total. How I do know that? I can write total and press enter, and I'm going to have the 4. And I also have the variable up right in the environment tab. So here I have a variable that is called total. I have the number 4. And then I can use that total for doing other things. So I can say total divide by 2, and I will get 2. And I can do crazy stuff like this. I will say total divide by 2, and now total will have the 2 as the last value. So this is kind of different of what we do in a spreadsheet, because this will be like auto-reference calculation that the spreadsheet will tell us I can do that. So in a programming language, we can do this kind of stuff. Sometimes they're dangerous. Sometimes we need it, actually. So this is kind of the way to work sometimes when we want to try quick stuff, when we are learning about new functions. Sorry. For rename. Oh, yes, for renaming a variable, you can do some numbers, for example, and you say total. And then some numbers we have the same as total. So you don't need, you usually are not going to rename, but if you wants to change the name, that is one of the ways to do it. So yeah, that is a way that you can work on that. Thank you for the question. So for the people who couldn't download RStudio to their machine, you can use this RStudio Cloud project that is the same that I'm doing, and that works on your browser. So you don't need to install anything on your computer. Okay. So this way of work, as I say, is something that is useful when you need to do some quick stuff, but it's not so useful on that goal that I mentioned at the beginning of having a receipt with our steps for our analysis. For doing that, everything we write should be in one file. And right now in R, we have 3 different files that we can save code for reusing that in the future. And that is our scripts, our Markdown reports, or Quarto reports. So today I will show you our Markdown. That is pretty similar to Quarto, and Quarto is kind of the future of these things. So I will start to show you one report that we create as an example for this course, with the idea to see what parts have and how we can work with these notebooks. Markdown and Quarto are what that we call in programming notebooks that mix text and explanation with code, which is pretty cool for having self-explanatory analysis and for reproducibility. Yeah, and also can save us time on automation tasks, because the document, the report, will recreate all your filter analysis and plots every time that you run that code. So instead, if you're in a spreadsheet, sometimes you need to do the report in Word, or you have to do a presentation in PowerPoint. So you are going to have to go to the spreadsheet, do the plot, made it pretty nice, copy and paste to the other document, and then you realize that you have a typo, and then you have to go back to the spreadsheet, do the changes, and do it that again. In the case of the Markdown or quarter report, you have everything in the same file, so you don't need to go back and forth on different files and different software. And the nice thing is, as we are going to see, is that you can also create a PDF or Word document from an Markdown. So that is kind of pretty cool. So if you are in the project like me, we have in the Files tab a file that is called Penguins report.rmd. We are going to click that and open. So we can check. Now we are going to have a new panel that opens above the console. And that is already have a lot of information. This is a Markdown report. The nice thing is that this is a file that I can share with other people. I can send it through email. I can share in a Google Drive, and other person who wants to see the report can take that Markdown and check it with R, which is also pretty cool to share code and share analysis. I will invite you to click on this yarn, blue yarn that say knit, to run the document and check how this looks like as the finished document. So I will click here. Perhaps to some of you will open a window. Please click on try anyway. I think that is the button. If that happens, for me, it's open here in the viewer, because I want to show you what part of the report is how that looks in code. So this is a report about penguins, the Gentoo species. So we have an intro about the data with some links. We have a table. Then we have some plots over here. The code that generates this report is this code here. And let's check out how we write the code and how that looks in the report. In the Markdown, we see that we have some text with white background and some other text that has gray background. And then we have text in green, in black, and in blue. So this means different things. The most important is that the text that is with a white background is text that I can write, and it's not code, programming code. It is how I explain what is this report about. So, for example, here the title, Gentoo Penguins, is here, the title is what I have appeared here. And then we have about the data, that is a header. So here we have about the data. So this hashtag, 1 hashtag 2, 3, or 4 is going to create headers or subheaders. More hashtag, more small the text. Then we have this explanation. It is the text that we have here. So the text that is with 2 asterisks is bold. And the text that is with the, how you call this, square brackets, that is the name. And then you have parentheses, and the link will become a link on the text. And then here we have a table. If we check in the source of the Markdown, we don't have a table. What we have is this chunk of code, and this has gray on the background. So this table is an outcome from this R code that is here. And that is what I say, that if you need to change anything, it's not that you need to go and make the change by hand and then export the plot again or the table again to put it in a Word document. You will come and make changes here. And those changes will be impact in the outcome. Vic, if you don't, I'm reading the chat now. So Vic, if you don't have in the viewer, it should be in another window. It should open in a separate window. So let me know if that happens. Oh, okay. Yes, the other way to, if anyone wants to do this locally, I will share with you on the chat. There is in that file that I just shared on the chat, you will find the 0.6. It says download this project, and it is the same project that it is in the RStudio Cloud. So you can do it locally with your computer. Yeah, for Vic, for seeing in the viewer, I will show you. You have to go to Tools, this option here, Tools, then Global Options, Tools, Global Options, then go to Armor Down, this one with the purple circle, and here show output preview in and choose Viewer Pane, Viewer Pane. If it is in window, will open in another window, and if say none, it will not show you anything. So it has to be Viewer Pane, and then go over here and click Apply. And then, okay. Let me know if that works. Okay, any questions, comments till now with the report? Okay, we can when we have a break, we can check out what is going on. The rest, everything is okay? Okay. Awesome. Thank you. Good. So Markdown is a markup language. What we call is, it is the kind of language that has some formatting syntaxes. This is like when we write for Wikipedia, for example, it has some syntaxes that we need to follow, so then the text is formatting in the right way. There is a lot of options. So here I only going to show you these 2 or 3 that I already mentioned. But in the website of the materials, you have a link to what we call a cheat sheet with a lot of other information on and details on Markdown syntaxes. So one of the important things to understand is this split between this is text and will be appear just like that on the result, and this is code, and the code will execute and show the results in the report. That was the table, and this is the code for one of these plot. And this is the code for this other plot. No, the changes, let's change anything. Let's change the title, for example, Gentoo Penguins Report 2025. You will have to need to see the changes. So for seeing now in the title, the report, I will need to go and need. So we click here. This will create the report. And now I see the change in the title. Great question. So let's say that your boss say, hey, I love the report about Gentoo penguins, but I really, really want to have the same report for chinstrap from one of the other species, this one. How will you do that, having this report? How can be one way to do that task? You can unmute yourself or you can write on the chat. My question is on the chat now. You say line 39, okay? What we have in line 39? Here. Yeah, if I change, you say that I should change Gentoo here for chinstrap. I can do that. Let's need. The thing is, the title is still Gentoo. I still have Gentoo here, Gentoo here. This is about Gentoo. So the thing is that we should look for every single time that in the report, the very title on the top. Yes, we can do kind of penguins and it's more neutral. It's not for any species. But the thing is that we have the Gentoo species, the word of the species, many times in the report. Can you please go through the report and count how many times that appear and let me know in the chat? Is there a way to do a replace? Yes, we can. Here in edit, we have replace and find, that I don't know what is. Yes. So we can here put Gentoo and copy chinstraps. And we can go next and say replace, 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 replace. 6, Megan say 14. I think that is kind of 9 or something like that. But yeah, there is in a lot of places. So if we have to do this kind of by hand, we can miss some. Perhaps we can break some code. We don't know if there is anything here in the code that will work if we do a final replace. And we actually have to do it every time. So we're going to see how we can add parameters and then choose what species we want, and the report will recreate with the correct data. it will be some kind of template. We call notebooks as Markdown. So what we are going to do is to add some parameters so we can actually choose, in this case, the species. So I used to work as a researcher at the National Institute of Agricultural Technology in Argentina. We have this monthly report related with weather, and there's always the same report every month. The only thing that changes is the data. So what we create this report, and after use it for several months, we even open that report and we allow people to choose the year and the month they would like to have the report. So they not only get the report for the weather, but what is going on now, but they actually can go on the history of data and recreate and have that information. So that is very cool because you write this once and then you can use it all the times you need it. Okay, so that is one of the things that we are going to do during the workshop at the end, mostly. So with that promise, I invite you now to try to recreate this report together. So we are going to start this penguins report from scratch. Before to going that, there is any questions that you have? Oh, I see one question say, will this change the data and the graph? Yes. Let's neat to see if we can see some change on the report. Oh, let me see. That can be my internet connection. So now we have chin strap. There is some less dots here. And I don't remember if I changed in this last one. Yeah, I also changed the species here. So yeah, the plot is a little bit different. So yeah, the idea is that here we change by hand, but when we add parameters, the report will filter the correct data and will do the plot and the table and everything we do on that filter, on that parameters that we use for the report. Okay. Did I miss any question? Okay, I will continue. Now, how we create this report from scratch? We are going to go to the menu. We're going to choose File, New File, and we are going to choose the fourth option, which is R Markdown. We are going to click there. It's going to ask for the title. This is the title for the report. It's not the name of the file. So we are going to put here report. Going to be really original 2025. And we are going to click in OK. So this create, check that the file is untitled yet. So that is what I say, the title is coming here. And we get a template for a Markdown report. Yes, I can, I will show again. So it's File, New File, and there is the fourth option, R Markdown. You click there and it will appear this window, and there you can put the name. Okay, well, awesome, thank you. So we will delete everything that is from the line 12 forward, because that is a template and we are not going to use that. And we are going to create our own report. So the first things we need to do is to actually read the data. I'm answering some questions on the chat. Just for clarifying, the reason because I have this in viewer mode is just because I want to show the outcome and how that looks in the source code. But if you have it in the window and opens another window for you, that is okay too. There is no need to have it in the viewer. So we are going to read the data. That is what we are going to do here. So because we are working with a spreadsheet, I would like to show you two functions that will allow us to read data in two formats. One in CSV format and the other one from Excel files. So one of the things we are going to do is, in this chunk, remember that everything that it has gray on the back, it is a chunk of code, of our code. We are going to add one line. For adding that line, I put my cursor at the end of the line 9 and I press enter. And here I will write library tidyverse. So what is this? This is a function, the function library, with load on the memory the tidyverse package. So R come with what we call base R that has a lot of functions. R was developed thinking on doing statistical analysis. It's really cool for that. It's amazing on visualization, and it's very good for modeling too. So base R come with a handful of set of functions that we can use, and then we can add more functionality to base R through packages. In this moment, R has more than 30,000 packages that add functionality to the language. And I love because that is a lot. Everything is open source, and a lot of these packages are developed by the community of our users and developers. So the tidyverse is a package that has a lot of functions that are great for data wrangling, reading data, data analysis, and some modeling. So that is why we are loading the tidyverse. Usually you will install packages one time per machine, and every time that you open a project, you will have to load those packages into memory so the functions are available to use. And the way of doing that is using this functions library and pass the name of the package as the parameter to the function. So I will execute this. We have several options for doing that. One is to run this play. We have like kind of play button there. So I can click there and that will run. I don't know if you were able to see the green line. That means that that code runs okay. And the other way to do it is to be with the cursor on the code and press Control Return or Control Enter. So we have a question to say, are these available from our desktop? I had to download the package into my desktop version. So when you install R in your computer, you are installing base R. And the packages, for having these packages, you need to install those, and you can do it through Tools. And the first option is Install Packages. And then you're going to write the name of the package here. So if I start writing tidyverse, it will at some point appear. And then you click Install. That is one of the ways. The other ways is to come to the console and write here install dot packages, and between how you call that? How do you how do you call that? What is the name? Quotes? Is quotes? Comillas? Uh, in inside quotes you write tidyverse. Sorry, people, English is not my first language. That is why sometimes I will ask you how I say this. So if you do this and press enter, it will install that package. It was that useful? Okay. So now that I have the tidyverse and all their functions available to use, the tidyverse has the read CSV function to read Excel files. Yeah, that's perfect. When you load library tidyverse, for some of you will get this message that was shared on the chat, that the only thing that is telling you is that the package load very good. R is really talkative, is loves to give you information of what is going on. Sometimes give the information in a red message, which sometimes is like, oh my God, what happens here? And it's only very excited to tell you that everything was okay. Unless that the word error appears, then usually it's a warning or choose information. So don't worry about it. Okay, let's go to read the data. So for reading the data, we need to write our code. So we need to add a chunk. For doing that, I'm going to this symbol, this plus C that we have here in the menu, and I'm going to click and I'm going to choose R. And that will create these three symbols, the brackets and the R letter. So it will tell you R that this is our code. And it will close in this way. So this is really, really important that the chunk start with this notation and finish with this notation. Everything that is in between, it will be our code. I will be trying to interpret our code. So that is important to know, because sometimes if we delete this, then we are going to have errors, because if we think that it will try to find the end of the chunk and will not find. Okay, so for reading the data, we are going to save that data in an object, in a variable. We are going to call that variable penguins. We are going to use the assign operator, the arrow, as we did with the sum. And we are going to use the function to read data. So the function starts with read. That okay, this symbol that I don't know the name. And if we pay attention, RStudio, this is the IDE, will give us a lot of option of functions that start with the name read. And this is really cool to see because we have a lot of functions for reading a lot of different type of data. So we have CSV, Excel, lines, RSDs, log. TSV is separate with tabs, more Excel files, the old format, the new format. This CSV, we have here, CSV2 is, for example, for people like me, that because we use the comma as a decimal separator, sometimes we use a semicolon to split columns, and that is what CSV2 do. Underscore, thank you for give me the name. So we write read underscore CSV, and as a parameter of the function, we need to give the name of the file that we are going to read. And before to complete that, I want you to show you where that data is. So in our project here, in the Files tab, we have Penguin report. This HTML file was created when we need the Penguins report, and we have a folder that is called data. If we click in that folder, we have two files, Penguin CSV and Penguin XLSX, which is the Excel file of the same data. So I will click again in project. So here we need to tell read CSV where the data is. So we know that it's in the data folder / Penguin CSV. I press tab for RStudio to show me the files that start with pen in the data folder. That is also kind of cool because you can save time typing, which is kind of nice. So with this code, we are going to read the data and put it into the Penguins variable, or Penguins object. Can anyone tell me how I run this code? Anyone remember how we can run this? Neat is a very good, but Megan is I was I was looking, yeah, very good, amazing. So yes, we have these two options: the green play, or being with the cursor in the code and press control return. So let's do the green one, which was the first one that comes. So we have some outcome here. And let's see, we have in the environment the penguin object now. And it's telling me that it has 344 observations and 8 variables. And here we have some more information, but let's check out a little bit how penguins looks like. So if we make click over the name of the variable, it will appear a view, and that is the most similar stuff that we are going to get inside R as in a spreadsheet. This is the view that will more similar. So here is also telling me some information. It's telling me showing 1 to 19 rows of 344, which is the same name of observations. and A columns. So the variables in R are columns, and the observation or cases are rows. And this is really, really important. This is what we as steady data. That is why the package is called tidyverse. So the idea of the steady data is that we are going to have one row for each observation of each case and one column for each variable. That is steady data. And this is the format that most of the functions in R are weighting the data has. For modeling, for calculation of statistics, for plotting, for summarizing, for everything, functions will be thinking that the data come with variables in columns and observations in rows. So we have some error here. What I need to be able to help you is also kind of the code. So if you want to pass there, I will follow a little bit and then we can stop and check the different error message that you are having. But if you copy the code will help me to try to figure it out the error. Okay, so this view will get by clicking on the name penguins on the environment, or by writing view penguins like it is here in the console. So now that we have the data, we just check the format with view, but we have some other functions to that allow us to check the structure and to have some glimpse or idea of how our data is formatted. So we are going to check two functions. One is glimpse, and I will wins. I did some Spanglish here. So if I run this, I choose click command return. Is give me this same information, and then is listing me all the variables, all the columns, some data as example of what is the content, and then it's appeared this that is interesting and important when we are working with data. That is the type of data. So it's telling me that species and Iceland is a character column. So usually we'll have text. And these other force that are in millimeters and grams are double. So it's telling me this is a number and has decimals. This is a character like the first two, and this is a double, which is strange because this is the year, and the year doesn't have any decimal. So this is something that we probably should fix at some point. We can change the type of columns of the data that we read, and we can make sure that every column has the right data. So we can do all the transformation and calculations that we need. Okay. So because of this, because sometimes data come with weird information or with some formatting that is not homogeneous in the column, because that can happen, especially if we use a spreadsheet. Sometimes people has to enter a number, but for some reason they couldn't have that record as a number, and we write some comment to clarify why there is not a number there. And when we read that in this in R, we need that all the data in the column is of the same time. So we can have some issues importing and reading that data. So for that, there is a lot of options to fix. And how do we know about those options? How do you get to know what you can do? When there is a function, we are going to use it in the console, which is the question mark that needs help. So for the question mark, I can ask for help on a function. So I will invite you to write question mark. We can write read CSV. And if we click enter, in the tab that is called help, it will appear an explanation of the functions, all the parameters that we can use. Just check that we write read CSV, but it's telling me there is exist read the lim, read CSV, read CSV2, read TSV. So I learned about a lot of other functions, an explanation of each one of those. And at the end, some examples of how to use that function. So this is a very is one of the most useful functions that we have, because it allows us to go to the help pages and get examples and get an explanation of what that function is doing. And this is very, very useful when we are using statistical methods, so we know how that is code. We will get a link to the paper that implement that method. So we are going to get a lot of information to know if that function is the appropriate one for the job that we want to do. So what about Excel files? So we can try to read. Let's add some text here in the line 25. Say reading Excel files. And I will add another chunk. Penguins XLS, just to have a different name. If I use this same name, it will rewrite the information. It will load the information from the Excel file in the CSV file. So to avoiding that, I'm adding this to the name of the object. So one of the things that we can do is to try to read with, we have Excel, we have XLS, XLSX. So one of those can be useful to read this. So let's try with read Excel, which is the first one. And let's see if this works or we have some error. So is the syntax is almost the same that this one. It has the same format. So let's run this. And we have here the data that was in the Excel file. Yeah, Ben, good question. So that was kind of the error that I was waiting for, because if we check, let me write here, write Excel, when we load the tidyverse, when we did library tidyverse, we load the reader package, which is the one that have real CSV and some of the other functions. So here is the name of the package that had the functions. But read Excel comes in a different package, which is real XL. So if you don't have that function, one of the reasons can be because we didn't load the package into memory. So we should do library read XL. We should run this and then run again this one. So try to add in library read Excel. And then run this one. So the idea was that I have an error, so I can show you that. But it looks like that I have already loaded all the package that I need. So the thing is that when we try to use a function and the package is not in the memory, it will give us an error. So we need to do the library. And if doing library read XL give you an error, like object read XL doesn't exist or something like that, then we need to install the package. So let me know if that works. Uh, if the package is already, you shouldn't need to reinstall. You need to do the install package is only one time per computer. You need to do the library, this loading into memory every time that you open RStudio and work with that project. But installing is only once. If perhaps there is some updates and then you can update the package and install it, but only when that kind of thing happens. Okay, cool, awesome. Okay, so one of the nice things that have this function, read Excel, is that if we have a workbook that we have several spreadsheet in that workbook, we can, there is a parameter that is called sheet, and you can put the name of which one of all that you have is the one that you want to import here. Here, because we didn't put any name, assume that was the first one that was in the workbook. And the other nice thing is that we have this other parameter that is called range. And we can say that we want to import from C1 to is 7. And we'll only load that information, that range from the spreadsheet. Let's do that. And if you can see now, Penguin XLS only has 6 observations and 3 variables, which is the ones that were in that range in the spreadsheet. So this is very useful when we bring information from Google Sheet or from an Excel file. Okay, so I will stop sharing the screen. And because we now have the data, I will invite you to have a little break. And when we return, we are going to start working with the penguins data. In the meantime, if you have questions, think about that and you have comment. And when we go back, I will give you a moment to ask those questions or to give me those comments. And then we will continue creating the report. Megan, that's a very good question, and I will share after the break. Manuela, okay, I will answer this too. Please continue doing the questions on the chat, and when we go back from the break, I will answer. Let's take 10 minutes. So I have a quarter past the hour, so 25, whatever is your time. See you again here. Okay. Okay. I hope the break was useful. I need it. I refill my tea. Um, I did a technical stop. So let me know if you are there. You can write on the chat. Okay. Thank you for the thumb ups. Awesome. Great. Cool. So I will start for asking the questions that we have in the chat. Megan say what happened if you don't have a Shani to ask about what packages are around there. So I will share with you three resources. Let me also share the screen so I can show you. And then I will answer Manuela questions because it will allow us to follow up on the report. So are you seeing my screen? Can you thumbs up? So I'm sure. And you can? Okay, great. So one of the first things that you can use is what we call CRAN task view. So CRAN is the archive where most of the R packages are available. So these task view are group package by topic or discipline. So if you want to do something about agriculture, you can click here and you will have a lot of the package names, what you can do with those package. So this is a way to find what do you need to use on R. So there is a lot of CRAN tax view. The other one is the R universe. R universe has all the packages that are on CRAN, all the packages that are on bioconductor, which is another R package archive, more focused on bioinformatics, and a lot of other packages that are not publishing in any of those places, but are on GitHub or GitLab or some of these other places where developer has their code. So again, here you can search by topic, weather, and you will get packages that has to do with weather data. So this is a way uh, to get information. And in our universe, when you click on one of the package, it will show you a summary of what the package does. And then we'll show you some cool stats here, for example, that say, okay, how much download this has, how many scripts on GitHub use this package, how many stars on GitHub has, and these are kind of statistics that allow you to know if the package is developed and used by the community, which usually means that will be a solution that will be there more time for and is safe for you to use. Is a sustainable software. So, and then we'll have really cool stuff like documentation. So these are use cases, how to cite, and some other information on how to use the package. So if the package has data sets, it will have it here, and you can download this data set in this all different format to use it. Articles are examples and documentations. So here you can have information on how to use that package. So it's pretty cool. That is really, really nice. That is our universe. And then if you want to use R for doing data science, data analysis and wrangling and some modeling and reporting, um, one of the advice is that you can go through the R for Data Science book, which is freely available in this website. And it's a really cool book. And then there is the Tidyverse website. Tidyverse is it's a package of packages that we are using today. And if you want to do modeling, Tidy Models is the other one. So I think that with that, you have the point to start digging on according to your needs or what you want to do with the language. Awesome, you're welcome. So returning to the use of read Excel, Manuela asked, when I did this reading of the penguin, the question was, does this mean that the Excel coordinate letter per cells are considered as the header? Well, in this case, the header of the column is the name only because we have C1, we start for the first row. If we don't start from the first row, let's say that we start in C3 and we load the data, then it will happen what you just say. It will take the first group of value as the name, but this is not correct. So we have a parameter here that we can call names false, and that will, otherwise the default behavior is that it will consider the first row that has the name of the column. So if we have this parameter and put call names equal false, it will not consider the first row as named columns. And what we'll do, it will name the columns like 1, 2, 3, 4, and as many columns as we import. So checking this, let's do this. So new names is using dot, 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 1, dot, 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 2. So if we check this here, now we have all the numbers correctly as row, and we have 1, 2, 3 as name of the column. If you, sorry, I'm going to move this over here. If you use the question mark with the read underscore Excel, the help will explain these parameters. That's how I get to know this that I'm showing you now. And here is also say that we can pass the names as a vector. So we can provide the names if we know that we are going to read from the middle of the spreadsheet, for example, and have the correct names in the columns. Yes, I can share the link to the book, of course. There is. Okay, any more questions before we continue with the report? Okay, if anything comes to your mind, please just put it in the chat, and I will try to answer as soon as I have a moment on the explanation. So we read the data, and now we would like to try to plot that information. And this is one of the most beautiful things that R have, which is the visualization aspect. We are going to put here plot penguins. And we are going to add an R chunk. And we are going to start plotting. So the package that we use to plot is called ggplot2 and is inside the tidyverse. So that is why we already have it that available. Otherwise, we should do library ggplot2. But as I already did library tidyverse, I already have ggplot available to use. So ggplot implement in R what is known as the grammar of graphics, which treat each plot as a different layers. And in these layers, we are going to have three main elements. One is the data. And in this case, we are going to use our penguins. Then we have the mapping, which is what part, what element of the plot I will link to what data in my data set. So every single element in the plot I can link to a variable in my data set, to a column. So it's not only the X and Y, it's not only the axis. I can link the color, I can link the labels, I can link the size of the symbols. And the third element is what we call the geometry, which is the symbols. It's going to be a square, a line, a point, and a polygon. What is going to be my plot? So with these three elements in different layers, I will create a plot. And for every plot that exists, that is the same logic. So the first things that we are going to do is to call the function that is called ggplot. And as I say, the first layer that we need to pass is the data. So let's put data equal penguins. And let's run this to see what happens. So I have a gray rectangle there. So, okay, I know that ggplot could read the data, but still can't plot anything because I still didn't tell what I want to plot and how I want to plot that. So this is the first layer, the data. The second layer will be the mapping. So we have this parameter, which is mapping. And here, we are going to start to link part of the plot to the variables. And this happens inside a function that is called AS, which means aesthetics. Because it is exactly that. It's how every element will behave in the plot, which is the aesthetics we want to use. So our first plot in the report was a scatter plot. So we are going to try to do that. So we are going to tell that the x-axis will be build length, the y-axis will be build depth. And let's run this to check what happens. This will be the second. Okay, thank you for letting me know, Iyare. So when I run this, now this gray rectangle that I have a little bit more of information. So we have build depth millimeters in the y-axis and already have the scale. And in the x, we have build length millimeters, and also we already have numbers according to the scale. How ggplot build this is because we have the data and it create the coordinate of the maximum and minimum value that that plot can have. Why it didn't show any data? Because we still didn't give the geometry. We still didn't tell ggplot if we want points, lines, bars, what we want. So that is the last layer that we need to add right now. For adding that layer, we are going to use the plus symbol, and I'm going to press enter just to be able to read more clearly the code, but it is okay if you follow writing here, but it's more hard to read. So that's what I hit enter. And here I'm going to write geom underscore, and I have a lot of options. AB line, area, bar, box plot, call, counter, crossbar, density, a lot of different density plots, histogram, and a lot. So we have a scatter plot, so we are going to, we want point. So we are going to use geom point. Every plot in R has this same logic: the data, the aesthetics, and the geometry. So let's run this and see what happens. Well, now we have points. It's still not so nice as the one we have in the report, but this is our first plot. One of the things that I want you to pay attention is that in the plot, we have at the beginning a warning. I'll say here warning, and it's telling us remove 2 rows containing missing values. So this means there's 2 rows that are missing, or the build depth or the build length value. And because one of those 2 values are missing, ggplot doesn't know where to put that dot in the plot. The ggplot still made the plot anyway, but it's letting us know that there is 2 rows less than the total rows in the dataset. This is important because we should go and check what is going on with these 2 cases that have some a missing value. Sometimes that is what happens in real life. You don't have the record, but the plot is still useful, and sometimes can be an error, and you have to fix it before to continue doing the analysis. So if when you check these points, this plot, there is anything that you can see that there's like, okay, this is something that grabbed my attention, that or something that you can say about this plot? Okay, Manuel is saying linear scale is adjusted, scattered. Two or three clusters, say Megan. Vic, I will answer that in a few minutes. So one of the things that we can do to try to visualize those things that we are kind of seeing in the information is to include other variables values in in the plot. And for that, we can take advantage of these aesthetics of the geometries. So, for example, we can paint with different colors the points. And we have some variables that perhaps can explain these clusters that we kind of see in the data to see if some of those variables can help us to explain that. So one of the things that we can do is to add an aesthetic, which is the same function that we have here. We can use it in the geometries, and we can give the color to one of the other variables, which is the species. Let's try. We also have sex, for example. Is there male or female? That can be another variable that can explain this, but it looks like there is 3 cluster more than 2. So let's try with the species that we have 3. Yeah, Megan, it's a 2 or 3 cluster. So let's see what happened here. So now we have the dots with the color according to the species that is as a legend here. Yes, for running, I come to the whatever of these 2 lines, ggplot or geom, and I'm with my cursor over there, and I hit command return or control enter, and that will run the code. And you can also click on this play green button here, and we'll do the same. Awesome. So here we, well, we can see that perhaps species can help us to understand these groups of points in the plot. Usually, data in real life is not so easy to check what the characteristics are. So we it's not enough to check the raw data or to have this kind of direct scatter plots to identify relationship between the variables. So usually you need to use some kind of statistical transformation to highlight those relationship. And usually one of the ways to doing that is to fit a model or calculate some statistics. So for ggplot, for each geom, we are going to have some calculation that ggplot does when it's creating the plot available. And there is one geometry that is called GeoSmooth that will allow us to fit a linear model to each species. So we are going to add a plus here, and following with this idea of each plot can have several layers, we are going to add another geometry to the plot. So we have the background, the axis, the layer, then we have the geom point, and we are going to add now geom smooth. And to geom smooth, if we run this like this right now, we have, this is the result. So we have this, we have only one model fit, and it's not linear. It has this format because what is using, if we read here on the bottom and at the first row in the plot, is telling us that the method that use is lowest. And the reason because it's using this method is because usually ggplot will choose the method according to the number of observations and columns that we have. So we need to tell ggplot that we want a linear model and that we want one linear model for each species, no one for the entire data set, and as in this case. So for giving those instructions to ggplot, we are going to use the aesthetic function with color equal species as we did with geopoint, and this will create one, it will fit one model for each value in a species, and we are going to add a second parameter, which is methods, and here we are going to tell LM, linear model. Again, if you say, how do you know that that is the name? I know because I prepared this workshop for today and I remember now, but otherwise I can always go to the help page to check which is the name of the model that I need. Mm? Always the help pages are very, very useful. So now if I run this, we should get 3 different lines in the plot, each one showing one model for each species. Let's see if that happens. So now we have what we thought in the beginning that we need. So here are the 3 linear model fit to each species. Any question, comments? Okay, so let's talk about a little bit about how the plot looks like. It is cool, but it could be improved. This is a plot that I will share with someone that I'm discussing the analysis. And if I want a really quick way to check the data and have a back and forth discussing this, is this is a plot that I will share. But this is not something that I will put in a report or communicate or send to my boss as a finishing visualization. Oh, we have a question in the chat. What is the difference between this and the plot options in the menu? You mean this one? These options are options for this tab, because because we are using an armor down, we are seeing the plots in the same notebook, in the same document. If we plot stuff in the console here, it will show here, and you will have these buttons that are the same that are in the menu to go from one plot to the other, to export and to zoom the plots. No, thank you for the question. So let's see how we can make this plot more finished for communication purpose. So usually I don't spend much time when I'm learning about my data and I'm trying to understand and trying to check how the models are working. But I will spend some times on my plots pretty when I have to send to a paper or a presentation or to official report to put in a web page. So how we can make this a little bit more nice. So one of the first things that we can work is the colors. So these are the default colors that ggplot will use. So if you don't change anything, you always are going to get the red, the green, the light blue, and go on in this default color scale. But we have a lot of scale options. And one of those options are color. So we also have a lot of color scales that are here already available. One of the ones that I use a lot is Viridis. Some of these color scales will be for continuous variables, some other for categorical variables. So how do you know? Because you can put right scale underscore color and start to read the yellow box that give us a quick help on that function. Or otherwise, you can go to the help page. So we are going to use this one, scale color manual, because I want to choose what color we are going to give to each one of the species. So in the scale color manual, one of the things we need to do is to give the values, as here the small help give to us. So we're going to say values, and we are going to use a new function that is called C, which will create a list of values. In this case, names of color. So we need 3 colors because we have 3 species. If we have 10 categories and we do this scale color manual, we need to write 10 different colors. And the colors that we are going to use is dark orange, which is the one that we have in the report. The other will be purple, which is the other color that we have in the original report, and CM4, which is the other one. So how I choose this color is because the people who create the penguin data set also create documentation and really nice illustration that use this color. So I take what the author of the data set that we are using did. So I will execute this to see how the color change, and that looks, at least for me, more nice than the previous plot. Okay, I'm reading the chat. I think that I think the message was sent only to me. So what the error is telling you is that the plus has to be always at the end of each line. Probably you have something like that, and that will give you that error. Or if you have the plus like this by themselves, like that can be what is going on with that error. Always the plus is at the end of the line, and after you put the plus, you can hit enter, but not before the plus. And every plus will indicate ggplot that we are asking for a new layer. That is why the plus is kind of cool. It's like, okay, I have this layer, and now I want to add this and this and this. We can have a lot of geom in the same plot, and we can add more layers of information, like the scale that we did now. So other thing that we need to do here is to have nice names or in the axis and a title, and to indicate where the data come from and that kind of information. And for that, we are going to add another new layer that is called labs, and the name comes from labels. So we are going to change labels from different part of the plots. And for this one, I will be a little cheat, and I will copy, and I will share that in the chat so you can also copy and paste this, so we don't have to write that from scratch because it is a lot. So inside labs, I will copy this, but let's see each one of the elements to understand what labels are we changing. So in the line 38, we have the title. 39, we have a subtitle. Then we have X, so we are going to change this, this label here. We have Y, we are going to change the label of the Y axis. We have color, and this one will change the title of the legend. And this one is the more hard for me to remember. I have to, it was a time to say, I need to tattoo in my arm how I, how I change the label of the legend, because it's attached to the aesthetic we use. If we check the aesthetic in GeoPoint and in GeoSmooth, the aesthetic is color. So if I want to change this title, I need to use the color aesthetic also in labels. And shape is for the dots. So let's run this and let's check how this change. So now we have the title, subtitle. We change the label, title 2, and the two labels in the X and Y axis. And this is a plot that is more for use in some presentation. We have a lot of more things that we can do with ggplot. It has many functions. One of the last that I want to show you is one that is called theme. And these themes has some configuration of how the plot width looks like. Some of these, I don't remember exactly which one now, I think that is the classic one, implements the theme that you need for plots for most of the journals. So it will already apply the formatting that you need. I will choose thin minimal so we can see the difference. So I add thin minimal here. I will run this, and anyone see the difference between the previous plot and this one with thin minimal? No one? The background, yes, exactly. Yeah, the background on the bars, yes, exactly. It's this. We don't have that gray stuff on the back anymore, and the lines are also in gray and are the main ones, not the secondary ones. And also it doesn't have the axis kind of disappear and the font. So yeah. I will copy and paste everything on the chat so you have kind of the final plot available. Okay, so we read data and we have our plot. Now, oh, there is people who can't copy from the chat. Okay, sorry, I didn't know that. So you still can find the all the code and information in the website that I share, the link from this workshop. So you have everything there available. Pretty similar to what we are doing here right now. Okay, so I will like for us to do some data manipulation now that we have a plot. So we can have some table in our report. So let's put that that title. One of the things that I still didn't do until now is to actually save our report. So I will click on this diskette. You are young, you are mostly young people, so I don't know if you know what is this, but this was kind of the USB of my time when I was young. So I will post this report 2025. So you know, Megan, I feel good. I feel good. So I will save this and I will need a report so we can see how this is going, what we have created. This is generating the report now. And here we have the report with the data, plot penguins, and tables and summary. So one of the things that happens in this report is that it's showing me the code. Do you remember that in our original report, we only see the outcome. We only have the table or the plot. And here we have everything. We have the code and we have the result. So how we manage that? Well, those are chunk options. So I'm going to come to the plot, and in the chunk we have this gear here on the right side, and if we click here, we can change the things that the chunk will show on the report. And I will click here and I will choose show output only. One of the things that happen is that we now have an echo equal false. So this means that the code will not be shown on the report. Let's see if that is true. So let's knit. And now if we check, while we have the plot, we still have the warnings. So one of the things that we can also say is in the plot here to say that don't show warnings, don't show messages. So here we have message equal false, warning equal false. Let's apply, and if we knit again, now we have plot penguins and only the plot. how I end a code chunk. Um, my advice is that you always add the code chunk from here. So you will always have the beginning, which is like this, and the end, which is with that symbol that I don't know the name. But are those three stick that are like kind of a little like the wind were pushing them. So you always need these two things, this beginning and this end. But the best way to do it is to choose from here. You can also add as, I think there is Option Command E. Yeah, it is Control Alt E at this letter, L plus Alt plus E, or Control plus Command plus E. That this is depend if it is Windows or Mac. Okay, awesome. So we did a lot of work. Let's do some data manipulation, yeah? One of the nice things that the tidyverse have is that we have a lot of functions that are called verbs that allow us to do different actions and tasks with our data. So we have a verb to group data, a verb to summarize our data, a verb to filter, a verb to mutate. So mutate our data is for when we need to calculate a new column or to do some transformation in the column. So we mutate. And the functions has the name of those verbs. So one of the things that we are going to do is to summarize the data by species. That is the way that we have in our report. So for that, I'm going to introduce also another new concept that is called pipe. And the pipe allow us to send the result of a function to the next one, like in a pipe. So we are going to take the penguins data, and that is how the pipe looks like. That is one of the pipe, or you can see in this way. These are the two ways. I'm going to write those on the chat. So the difference between the two is that the first one is base R pipe. So when you install R, and if you don't have any package, you can use that one. And the second one is a pipe that comes in the tidyverse. So I'm going to use this one just because we already load the tidyverse, but it should work with any of those pipes. So here we are going to say, take the penguin data and then pass that to the group by function. And I want to group by what variable? For what variable we want to group? Anyone? For species. Yeah, exactly. So our report was by species. we could decide, hey, I want a report for each one of the islands where the species were, or I want a report for sex, or I want a report by year, whatever we want the report by, we need to group by that variable. But in this case, we have a species. Okay, having some errors. This can be my internet too. So, and then I can make calculations. Oh, sorry for that. I will reload the project. So after that I group, one of the things we can do is to do calculations on those groups. So this in a spreadsheet, this looks like a lot on these summary tables. Sometimes we have pivot tables, and we can calculate different measure average or totals and maximum and minimums value on those categories. So that is how this looks like in RStudio and in R. So species was what I wrote here. And then the verb to do summaries is summarize. And here I can make those calculations that I just mentioned. So for example, I can say count is equal to, the function is n, because that is how we usually talk about quantity. How many observations we have is the n of that sample, of that population that we are studying. Then I can see, okay, mean body mass, and I will calculate the mean. For that, we'll say body mass G. And I can max body mass. It will be max and the name of the variable, body mass G. And I can add any kind of measure that I need. So I will run this and let's see what happened with this. Okay, so we have one row for each species, which is correct because we have grouped by species. So even when we have 344 observations, we are only getting 3 rows because are the groups we made. Then we have the count, what is the number of observations for each species, 152, 68, 124. And then we have this NA. So what happened here? Do any of you have any idea that can happen here? If we go and look to the data, and we go to the body mass column, we see here that we have some missing data. Exactly, yeah, Ben. Manuela said categorical data by mistake included. We usually will have that because we have an A. This missing data can be because in the original data set was like that, or because it was in a different type than the rest of the column, and then was dismissed when the R read all the values. So what we need here is to be able to calculate the mean and the max anyway, even when we have missing values. The result is correct, because if you have a missing value, any calculation that you do, the result is missing value because you don't know. You don't know what that missing value was, so you don't know how the total or the minimum or the average or whatever is. But that is not useful. So we have this parameter that is called NARM equals true, which is telling these functions that if they found missing values, please don't take it into account and do the calculation anyway. So I add that information here, and when I run again, now we have a result for each one of the row. I have one question for you. How this result will looks like if I remove line 53, if I remove this one, the one that group by species, how the result will be here. It is choose the total, say, yeah, exactly, choose one row. Let's run that. Let's see. What I did here is I add this hashtag that in code means that now this is a comment. So it's telling R, don't take into account this. Don't run, don't execute this code. This is a comment, which is different from the hashtag outside the code chunk, which is take as a title, as a header. So let's run this. And we have only one row, which is the entire data set all together. Exactly. Really cool. I'm going to go back to the original, so we have the groups. Okay, so let's say that we want to have, because we have this report that we do by species, that we only want to have all these results by Gen 2 species, which is the ones that we have on the report. So the way to do a subset of the data that I have available is to use the filter verb, the filter function. So one of the things that I can do here is we can do it before or after. It is before the summarize or after the summarize. But we can put here filter, and in filter I can do species equal, which here we have to use two equals to say, to indicate R that we are comparing these two options. And here I will use Gen 2. And I have to add the pipe. So here I'm saying, take the penguin data and then group by species, and then filter and keep only the result for Gen 2, and then summarize and count the number of cases, calculate the mean of the body mass, and calculate the maximum value of the body mass. That is what I'm saying in this set of instructions. So let's see what happens. And now I have only one row, what is changed. Yeah, it is case sensitive. True is always with capital letters because it's an object. Okay, so now we filter and we have those data calculated by the Gen2 species. I have two questions for you. Let's go to check the entire data set. Let's say that I will keep all the observations in the Torgersen Island. So I will copy this. How will you write the code for doing that? For keeping only the observation in that islands? How will be? Should I write that pipe to accomplish that goal? What is the start of the pipe? The first things that I need to give. It is a filter and then penguin. Yes, exactly. I'm reading in the chat. So the first thing is the data. So I will put penguins and say, okay, take penguins and then filter. And in the filter, what I should write? Is the name of the variable, which is Iceland, and then equals, and the name of the island that I want. So if I run this, it's giving me 52 observations. And all of them have this name that is really hard to say. And with all the columns. And if I want to keep all the penguins with a flipper length greater than 100, how I do that filter? The first line is easy. Tell me the first line. What I should write there? I will write here what the conditions were. It's like wins with a flipper length greater than 100. How we do that? Okay. Ben is, I'm going to copy what Ben just shared on the chat. The first thing is always to pass the data. So we are going to need to pipe penguins always at the beginning. And then we have filter. Okay, here I will, if we have this red X here, which is signal us that you have a syntax error here, it's telling me. So I know which the syntax error is here, is because we have two equals. So we only use that when we are going to compare with one value. But we need to compare with greater than or less than, or for example, different or not equal we are going to use only one equal. So let's try this one. Okay, I just move this to write it in this way. And now if we check flipper length, we should have all greater than 100. And it looks like that is correct. If we want more than one condition, we can add those conditions on the same filter, split by a comma. So this will keep all the observations that the flipper length is greater than 100 and the Iceland is equal to Torgersen. So we have now these two conditions on the result. And I have one last question, the final question on this topic for you. Until now, we are doing this and we are seeing the results, but we are not storing this in any variable or object. If I want to store this data set to use it in some other filter, in some other analysis, how I do that? How I instead to see the result here, how I save that in the way that we save total or sum numbers, how I have that information available in an object so I can use it in another place with that name. I had to put the var name at the beginning, so we can put here, let's say, Torgersen Iceland. And what else? We can use the equal, but it's not how things in R you are going. Yeah, exactly. When the equal is going to work in R, but most of the code that you are going to see in books, in examples, in everywhere, in internet, in LLMs, in any place, is going to use this arrow. So this is the way. So if I run this now, I don't see anything in the outcome, and I have Torgersen Iceland data set here in the memory ready to be used. So if I enter here, it's the same, but with those two conditions that we add. Yeah? Any question? Okay. So we are going to do a small break, 5 minutes this time, and then we are going to see the parameters and some other small stuff to continue. Yes, on the saving, what I did was, let's do it with the previous one. So here we have these filters by the Iceland. So when I execute here, it shows me the result here. Let's say that I want to save that data set to use in other analysis. I can put here the name, Iceland T, let's say, and I will add the arrow. And then it comes the pipe. And in that way, if I run this, I don't see the result anymore here. And I have now an object that is called Iceland tea in the environment of R. We do that when we have sometimes, for example, this can be something that I will save in an object, and then I will use the object, for example, to write a table and put it really, really nice, for example. So sometimes pipes, these kind of pipes has so many steps that it's good to save in an object when we filter and do some transformation, and then use the object, use that data set that I save to plot, for example, or to do other calculation, other summaries, and yeah, and task. Okay, let's do this little break and let's go back here in 5 minutes. Okay, that was short. Was really, really a quick break. But I really want to show you the last things on the report. So, okay, thank you, Megan, for the thumbs up. If any other people give me some clue that you are there, I will restart with the last two or three ticks. Okay, I see yes. Awesome. I will be sharing the screen while some other people react. Okay, I will open the chat. Awesome. So some people were asking if this is will be recorded, and it is. We are recording this, and then the institute will share with you the video of the workshop. Okay, so I promise you two things when we start. I promise you to be able to share this in different formats. I say that you don't need to go outside Armardown to create a Word document or a PDF. And I also promise you to have a way to change the variable and then the report change accordingly to what we choose. So I want we to do that in the time that we have. So I will go back to our original report, the penguins one. And the first things that I want to show you is to change the format of the outcome. So we have here from the line 1 to 4, we have a encabezado, yeah, header that is called YALM. I will write that in the chat, and it means yet another markup language, which is very fun. And uh, in this part of the document, we have this key and value way of write configuration options of the document. So here in the output, we are telling that we want an HTML document. So HTMLs are web page. So every single time that we saw in the viewer, we are seeing an web page document. We can also say, hey, I want a PDF document. So the only thing that I did is line 3. I change HTML for PDF, and I can knit. And what will happen is that the first time that you run this, perhaps you will get this warning, and you only have to click on try again, and a window will appear. And this is a PDF file with a report. It is the same that we have in the Markdown. I don't know you, but for me, this was a game changer because I can have the same source and have different format. This kind of blew my mind the first time that I saw that I could do this. And I can also do the same with Word. So instead of PDF, I can write Word and knit. And because I'm in RStudio Cloud, it's asking me to download the file. So if you check, the name is report doc. So I will download that file and I will open in my machine so you can check that is a Word document. I'm open the file now and I will move to the window so you can see it. So here is the report, the plots, the text, the plot, the table. And I can edit that table, the link. So everything is there. Let me see, Vic, what that can be. It should be like this. You should have the YALM formatted on like this. So yeah, here you have to be careful that it has the word has to be, you need the space, and you need this, you need to have this. Yeah, the date should be, probably is that, I don't know. Let me see. Sometimes it's hard to see hidden symbols, but 2025, 11. Let me see. Yeah, no, I don't. Perhaps it's another issue that I'm not seeing here with that image. Oh yeah, I go back to the penguin report. Yes, I go back to the penguin report. So we can do what I promised at the beginning with the parameters and everything. So yeah. But it sure works in the other one anyway. It is the same. It should work in this one. The other ones to do this, if you don't want to change by hand, we can go to, sorry, here in the nicked button, we have this triangle that if we click there, we have the options. So we can say, okay, let's nick to PDF. It will appear this this warning, and we just click on try again. And that we open the PDFs. And this is with the report that I was building with you on during the lesson. So this can be something that I'm not seeing in the image. So sorry for that. So this is a way to, this is very useful. For me, this was something that it helps a lot. For example, for this report that I mentioned on my institution, to these monthly reports, we needed in different formats. So we were able to create the HTML to put in a website, and then we were also able to create the PDFs to send to different institutions that like the report, to get the report through email. So that was very cool, because with the same notebook, with the same markdown, we can have both formats, well format with all the information, without any need to copy and paste and be sure that the margin and everything that happens when you need to work with Word, especially, that sometimes can be tricky. Okay, so the other thing that we discussed was to add the parameters. So to be able to say, okay, let's be able to have the report by species. So for doing that, in the YALM, in this header that the document has, that is always between these three lines, we are going to go to the last one, and we are going to add the key params. And this is the way I will copy on the, chat. And here we can add the name of the variables that we are going to use to parametricize this report. So here is a species, and we are going to put Gen2 as the default one because it was the ones that we have in the report. Now, adding the species is not enough, as we saw, so we need to go through the report, but only one time, and to replace with these params species in the different parts that the report use the species. So we are going to change here in the group by. So the name of the param is, I'm going to copy this species. So this is the table of all the species, so I don't need to change here in the filter. So species equals, and instead of the name, we are going to put a species, a money symbol, and the name, right, is params, money symbol, species, which is the name of the variable. So this what it say is replace what is here with the value that is in the parameter. So in this case, it will take Gen2. We also have the same here. So we are going to put params, money symbol, species. We have some, okay, here we have the name. How we add code in the text, because this, remember that if you have the white background, this will take as text, not as our code. And we need our code to be able to access the value in the parameter. So how we do that? Well, there is this is called inline coding, and we can add those writing the two stick the R letter to indicate that this will be our code, and then we write params, money symbol, species. And this will write whatever value is in that parameter. It will replace and put that text or that value here. So here we have another one, and we're going to do the same. Do I missing anything? Well, here can be a little more tricky. So let's here have typo. Okay. Okay. Okay, let's knit this to see what happened. Oh, okay. Let's change this for, let's go back to the HTML so we can see it more easily than the Word document. Okay. So this shoe looks like the original one because oh, that is interesting. What happened here? Why we have white spots? What happened? What's the problem? Yes, exactly, Ben. Yes, yes. It is case sensitive because it's Gen2 with capital. Let's knit one more time. And now we have the plots. This is the original one. So now let's change the species. So because I clearly don't remember how to how to write that, let's copy one of the other species and change here and knit to check if that change. So now we have the name here, the plot, and let's do it with the last one. So we can chinstrap. We can see the differences. Yeah, we can see that it's less dots and the histogram is also different. And we have here and here the change of the text. So I'm going to, I'm seeing some people asking me for some errors. So sorry that I didn't get to answer. I'm seeing some issues that can be because of the YALM, because this part here, I need to clarify that the YALMs need to have this name just like that, like no capital letters, no space between them. We need this symbol after the names of the key. So if we have missing, I don't know how you call that, es dos puntos, two dots, I don't know the name. So you are also can get an error, and then you need the name of the variable. So that is one thing, and the other thing is that we need the indentation. So if we write params, and a species has to be more indented below params, or you are going to get an error. So just check that all this is in the correct format, and that can be part of the issue with the YAL. So yeah, we have to be careful on that. No, thank you all. So yeah, I'm going to stop here because this is mostly what I want to show you. I really, really hope that was useful. Thank you for those who engage and answer my questions and share your code and your questions. Yeah, I'm glad to learn how you are using R. And if you want to learn more, don't hesitate to contact me. It will be I will be very glad to help you.